So in today's lecture, we are continuing the SHM, the linear SHM equation. In the previous lecture, we have seen then if a particle is performing SHM, right? So about its mean position, this is the right extreme, this is the left extreme. The maximum displacement is called from the mean position is called the amplitude. The time period is called the time complete to one oscillation, right? On that, and if the special case when the particle start its motion from t is equal to 0 from the mean position, right? In the further cases we will see the particle may start its motion from positive extreme or negative extreme, but here if the particle start from mean position, its displacement is given by a sin omega t, right? Velocity is given by a omega cos omega t, and the acceleration is given by minus a omega square sin omega t. So these are the displacement, velocity and acceleration as a function of time t. Now we see the other form, how to represent the velocity in terms of x. For example, if this is the velocity, it is equal to a omega. What is the cos omega t? Using sin square omega t plus cos square omega t is equal to 1, right? The cos square omega t may be written as 1 minus sin square omega t, and if you take this is the square root. So in place of cos omega t, I can write sin square omega t. Is it clear? If you multiply by a in the square root, if it is inside, then it may be written as sin square omega t. Is it clear or not? Right. So this is a square minus a sin omega t whole square. A sin omega t is nothing but the displacement. So velocity may be written as root over a square minus x square. So this is the velocity of the particle, velocity of particle performing SHM, performing SHM. Is it clear or not? Vx is equal to omega root over a square minus x square. So this is the velocity. Can you draw the graph between the velocity and x? X is the displacement from the mean position, right? For example, if this is the mean position, x is equal to 0. This is the minus a, this is the plus a, right? This is the object is performing oscillation about its mean position. If you draw the graph between velocity and the x, so you tell me at x is equal to 0, right? At x is equal to 0, you can leave a little space, because here I will make the graph of the acceleration, right, versus x, right? So listen one thing, if x is equal to 0, what is the velocity at the mean position? Omega a square minus 0 is equal to a omega, right? It is not the velocity, rather you will say it is the speed of the particle, right? You may write this the speed because it is always positive, right? So at x is equal to 0, the speed is what? Say a omega, right? And x is equal to plus minus a, that is on the here the velocity is a omega, right? Towards the left also the towards right, and extreme position, right? Extreme position is equal to plus minus a, the omega root over a square minus a square, it is 0, right? And this is the variation in the speed and the x as a hyperbolic expansion, right? Like this. Are you getting or not? This is the thing, right? Wait for 1 minute. You may make like this, right? This is the graph. It is better to write in this way, right? This is the plus a, this is minus a, right? Here at plus a, the velocity or the speed is 0. This is x is equal to plus a, the speed is 0, x is equal to minus a, the speed is again 0. Are you getting or not? And x is equal to 0 at the mean position, the speed is omega, right? this is the velocity versus x graph. Is it clear? Copy this first. So this is the variation of the velocity versus displacement graph. Now we see how the acceleration is related to the x, right? For example, you may write this side. The acceleration is minus a omega square sine omega t, which may be written as omega square minus a sine omega t. Fine. And a sine omega t is nothing but x. So acceleration is equal to minus x. So if you draw the graph, this is the acceleration as a function of x minus omega square x. So you tell me at x is equal to 0, that is at mean position, what is the acceleration? Say 0. X is equal to plus a, that is at this point, the extreme position. The acceleration at x is equal to plus a is equal to minus omega square a. X is equal to minus a, that is at left extreme position, right? Minus a is equal to minus plus, it become plus a omega square, right? Here this is the acceleration as a function of x, and acceleration is proportional to, right? Acceleration proportional to minus x. So if you draw the graph between the acceleration and the displacement, right, acceleration, it is like this, right, with negative slope. At x is equal to minus a, what is the x is equal to minus a? The acceleration is plus a omega square, and x is equal to plus a, the acceleration is minus a omega square. So this is the variation, this is the acceleration versus x graph, and this is the velocity, right, or the speed versus x graph variation, right? Copy this. So listen one thing, although this is the relation, right, between the speed, v is equal to, you have to remember the v is equal to omega root over a square minus x square, right? Although this is the graph, but the complete graph you may write like this: v square upon omega square is equal to a square minus x square, v square is equal to omega square, right, plus x square is equal to a square, right? So v square upon a square omega square, when it comes in denominator, right, like this. Are you getting or not? So v square upon a omega plus x square upon a square is equal to 1, right? So the ellipse equation, x square upon a square, y square upon b square is equal to 1. This is the equation when a is greater than b, right? And if a is less than b, then the equation is like this. This is the ellipse equation. So if you write this, x square upon a square plus v square upon a omega whole square is equal to 1. So x square upon a square, and this is the b square. So the equation of the ellipse will be like this, right? This is the elliptical variation between the x and the velocity. You may assume this is the y-axis, this is the x-axis. This is plus a, minus a, this is a omega, this is minus a omega. The thing is same, right? In this figure, I have only made the upper half, right? Right, and it will be the lower half, right? So it is a complete graph, it is given in the book, that's why I have made this, right? Copy this. So we have seen the velocity as a function of x, a square minus x square. Is it clear or not? This is the speed as a function of x. So for example, if you consider an illustration, right, the particle is performing SHM and the amplitude is a, right? This the x is equal to 0. When it reaches to the a by 2, can you find the speed when particle performing SHM and reaches to the half of its amplitude? When particle performing SHM of amplitude a reaches to the half of the amplitude, reaches to the position half of the amplitude. So what you have to do? Simple. You will use the formula. And what is that formula? Please tell. Here the velocity we have to find, right? This velocity we have to find. So we will use the formula. And the x value we will put a by 2. So if you put the x value a by 2 is equal to omega root over a square minus a square by 4. Right. So this is omega 3a square by 4. So when you will simplify this, so a omega root 3 by 2 is the correct answer. A omega root 3 by 2 is the correct answer. Fine. This is the velocity a by 2. All right. This is the solution. So by putting the different values of x, you can find the speed at any point. Listen, one more thing. If you consider whether the particle is moving right at x is equal to a by 2 towards the left, its velocity will be what? A omega root 3 by 2 in the positive x direction when it will be returning back, right, like this. So again the speed magnitude will be the same, only the direction will reverse, right? Also listen one thing, whether it is plus a by 2, right, or whether it is, suppose this is the minus a and this is the position minus a by 2, is it clear or not? So if you put x is equal to plus a by 2 or minus a by 2, right, the velocity minus at minus a by 2 towards the left extreme will be, again if you put minus a by 2, it will be a square by 4, and this is a omega root 3 by 2 will be the same speed, whether it is going towards left or whether it is going towards right, right? So its speed will be equal to a omega root 3 by 2. Are you getting or not? A omega root 3 by 2. Fine. Copy this. So also they can ask the acceleration at this point, any point, not only a by 2, half of the amplitude, rather a upon root 2, whatever the value of a we give, you can get the velocity as well as acceleration. Can you find also find acceleration at x is equal to a by 2 and x is equal to plus minus a by 2, right? So how to do that? Please tell. Acceleration formula is omega square into x. This is the acceleration as a function of x. So at x is equal to a by 2 plus a by 2. What is the acceleration of this particle? Minus plus a by 2. So the acceleration is minus a omega square by 2. It means whenever it is moving towards right or left, right, it does not matter. The acceleration is towards mean position, it shows, and the magnitude of the acceleration will be equal to what? A omega square. This is a omega square by 2, and the minus sign shows towards the mean position, towards left. If you put x is equal to minus a by 2, the acceleration you may write minus omega square, and the x value is minus a by 2 is equal to plus a omega square by 2. Plus a omega square by 2 mean the particle is at minus a by 2, and here the acceleration will be in this direction, plus a omega square by 2. Mean this is the velocity as a function of x, and this is the acceleration as a function of x for different value of the x during the SHM, right? You can find the velocity and acceleration by putting the value of x. All right, copy this. So in the next example, suppose this is the particle performing SHM between plus a and minus a. All right, and this is x is equal to 0. If particle start from mean position at t is equal to 0, so it will moving in this way. So when particle reaches at x is equal to a by 2, from mean position to half of its amplitude, the time is supposed to be t1, right? And from half amplitude to the extreme position, right, plus a by a, the time taken is, suppose it is t2, it is t1. Are you getting or not? So you have to find the time t1 and t2, right? Find time taken by particle performing SHM, first from mean position to mean position to half of amplitude, right? Amplitude. Second, from x is equal to half of the amplitude to x is equal to a, the extreme position. So this t1 and t2 we have to find. So let's see how to find the time. Whenever they ask the time, so we will use the equation, right? At x is equal to a sine omega t. When the particle start from mean position, listen, the original and basic equation of performing SHM is sine omega t plus phi, right? Phi is the initial phase, and at t is equal to 0, when the particle start from mean position, the phi becomes 0. Therefore, I am writing it is the sine omega t, right? We will discuss few questions where the phi is other than 0, but initially we are considering this basic example, right? So if the particle start from mean position initially at t is equal to 0, the displacement is given by a sine omega t, all right? So when it reaches to the a by 2, as the time is changing, right, the position is changing. You tell me first of all, if it is t is equal to 0, at what time it reaches to the positive extreme? Can you tell? Yes, Varsha. If total time period is capital T, this is the one oscillation. It move like this, move like this, move like this, and move like this. So what is the time I am asking you? From 0 to A. What is the time? Time interval. Total time is what? From here to here, here to here, here to here. Total time of oscillation is what? Say capital T. Are you getting? Yesterday I told you from here to here what is the time? T by 4. That's the thing I am asking. So when it is at x is equal to a by 2, what should be the time? T by a particle perform. Yes. From here to here, the total time is t by 4. So it looks like the time should be half, amplitude should be t by 8 and t by 8. It is not so. Why it is not so? Because when the particle is moving, its velocity is not constant, right? So this time of a by 2 and remaining time of a by 2 is not same, right? How it is? Let us check. From x is equal to a by 2, when the position is a by 2, how to find the time? Put x value. It is 1 by 2 sine omega t. The 1 by 2 is equal to what? Sine 30 pi by 6 omega t. So what is pi by 6? Is equal to omega t. Therefore, pi by 6 is equal to 2 pi by t into t. So what is the value of t? Say t by 12. So this is the value of the t1, mean from x is equal to 0 to x is equal to half of the amplitude, not t by 8. You understand? Also, if you want to find the remaining time t2, how to find? This total time is what? Say t by 4, and this time is t1. So t2 is time what? T by 4 minus t by 12. Are you getting? When you simplify, 12, 3t minus t is equal to 2t by 12. So the answer will be t by 6. Is it clear or not? So you will always remember. What will you remember? It is used many times. From mean position to half of the amplitude, time taken is t by 12, and this remaining time is t by 6. Is it clear or not? Sometimes they also ask the ratio, of the time taken from mean to half and half to extreme position. So this is t by 12 and this is t by 6. So this is equal to 1 by 2. So they also ask some time ratio. Is it clear? It is not t by 8 and t by 8. Fine, copy this. So read this question. In this illustration, object perform SHM, the amplitude is 5 centimeter and the time period is 4 seconds. If time start when object is a center, it means this is the very special case. At t is equal to 0, the particle start from its center. Then calculate first the frequency of the oscillation. How? If the time period is 4 seconds, what is the time period mean? It start from here, it take 1 second, then similar 1 second, similar 1 second, and then 1 second. You understand this thing or not? You tell. So if the time period is 4 seconds given, so what is the frequency? 1 upon time period, 1 upon 4 hertz. That is, it is 0.25 hertz. This is the first option. The second option, the displacement at time t is equal to 0.5 second. Listen, what is the equation of SHM? Equation of SHM when particle start from mean position at t is equal to 0, the particle is at x is equal to 0, the equation of SHM is a sin omega t, right? What is the amplitude? Say 5 centimeter. What is the omega? Omega is nothing but 2 pi by t and 2 pi by 4. This is 1 by 2. So here 1 by 2 into t. Is it clear or not? You tell. So this is the displacement as a function of time t. What they are asking? They are asking the displacement at 0.5 second, right? So I will write the 0.5 sine, right? It is 1 by 2 into 0.5. Is it clear or not? Sine 2 pi by t is equal to 4. This is pi by 2, right? This is pi by 2. Omega is pi by 2 into t. The t value is 0.5. This is pi by 2. So it comes to be sine pi by 4. Are you getting or not? Sine pi by 4 value is 1 by root 2. So what is the displacement of the particle? 5 by root 2 centimeter from the mean position. It means at t is equal to 0.5 second, right? It is not in the mean. Rather, it is at this displacement is 5 by root 2 centimeter. So particle is over there at t is equal to 0.5 second. Fine. First copy this. In the third part, they are asking the maximum acceleration, right? The formula of the acceleration is minus a omega x square. So when x is equal to, it depends upon a, it depends upon x. So when the x is maximum, like this, maximum acceleration is a omega square at x is equal to plus minus a. I am taking the magnitude, right? They are not asking the maximum acceleration is a omega square. The amplitude is 5 centimeter. Omega is pi by 2 whole square. It is equal to 5 pi square by 4. The unit is centimeter per second square. And the maximum acceleration occur at the left and the right extreme. Are you getting or not? The fourth part, they are asking the velocity at x is equal to 3 centimeter. What is the amplitude? The amplitude of the SHM is 5 centimeter, right? Like this. So it is x is equal to 0. So this is x is equal to 3. They are asking the velocity, right? So which formula we will use to find the velocity? Right. So the velocity as a function of x we have found in this way. Put the value of x, the omega value we have found, it is equal to pi by 2 root over a is what? The amplitude is 5 centimeter. Where the velocity to be found? At 3 square. So pi by 2, right, 25 minus 9 is equal to pi by 2 root 16. So it is equal to pi by 2, 4 is equal to 2 pi by 2 centimeter per second, right? So centimeter per second mean 2 into 3.14, it is 6.28 centimeter per second, right? Listen one thing, at the displacement x is equal to 3, the velocity may be towards right when it is moving away from the mean position, or the particle may be in this direction. So in the solution, that is why the velocity is taken to be plus minus at this point. So the velocity is 6.28 centimeter per second. You can write. Are you getting or not? Copy this. Read this question. For example, the amplitude of harmonic oscillator is A and the velocity is half of the maximum velocity. Can you tell me what is the maximum velocity? The maximum velocity is at the mean position and its value is equal to what? Tell me. A omega. So at the extreme position, right? Suppose this is the extreme position, the velocity when it is moving away, the velocity is decreasing and it becomes zero. So they are asking the position of the particle, this position of the particle when this velocity is half of the maximum velocity. Is it clear or not? So to find the position, we will use this formula. The velocity is a omega by 2. The maximum velocity is what? A omega. They are saying the velocity become half of the maximum velocity and they are asking the value of x. Omega will cancel out. A square by 4 is equal to a square minus x square. If you simplify, a square minus a square by 4, 3a square by 4, right? So here the x square is equal to 3a square by 4, all right? If you take the square root, plus minus a by 2 or root 3. What does it mean? It means there will be the two position, right? Also because it is symmetric. So here the velocity is at root 3 by 2a this side and root 3 by 2a this side, right? So velocity is a omega by 2, velocity is a omega by 2. It may be towards left, it may be towards right, right? Copy this. Read this question. In this question, the velocity of the particle at x1 is v1, at x2 is v2. The determination of the time period, you have to find the time period and the amplitude, right? So this is a very good question. Many times this is asked. We will use the formula a square minus x square, right? So for v1, x1, at displacement x1, the velocity is v1 and at x2, the velocity is v2. So how to find the amplitude and the time period? If you make the square, v1 square is equal to omega square, a square minus x1 square. This is the v2 square, square both side, a square minus x2 square. Is it clear or not? So this is equal to a square, omega square x1 square, a square omega square minus omega square x2 square. This is the equation number 1 and equation number 2. If you subtract the equation 1 minus 2, so this is minus plus. So v1 square minus v2 square, right? It will cancel out. So this is minus omega square x1 square plus omega square x2 square, right? If you take the omega square common, minus x1 square plus x2 square, this is v1 minus v2 square. Simplify this to find the value of omega square is equal to v1 minus v2 square, fine, divided by x2 square minus x1 square. Implies that you can write omega is equal to what? Square root of v1 minus v2 square x2 minus x1 square, right? And it is equal to what? Say 2 pi by t. So what is the time period you tell? The time period of oscillation is 2 pi root over x2 square minus x1 square v1 minus
v2 square, right? So the amplitude you have to find. How to find the amplitude? Listen one thing. This is the first equation. This is the second equation. The omega can be eliminated by dividing. Suppose this is the 1 and 2, right? So b1 upon b2, right? Divided by omega root over a square minus x1 square, a square minus x2 square. Omega will cancel out. Make the square both side. It is equal to a square minus x1 square, a square minus x2 square. Multiply a square v1 square minus v1 square x2 square, a square v2 square, right? And minus x1 square v2 square. If you simplify to find the value of a, the a square v1 square minus a square v2 square is equal to v1 square x2 square minus x1 and v2 square. All right. If you take a square common, right, you will get v1 square minus v2 square is equal to, this is v1 square x2 square minus v2 square x1 square. So here we can go for amplitude v1 x1 x2 v2 x1 divided by v1 minus v2 square. So what is the amplitude? Square root of v1 x2 square minus v2 x1 square divided by v1 square minus v2 square. Is it clear or not? Copy this. So read this question. The SHM having amplitude, right, is equal to 0.01 meter and the frequency is what? 60 hertz, right? So therefore omega is equal to what? 2 pi f, 2 pi into 60 is equal to 120 pi radian per second. Fine. What is the maximum acceleration formula? The maximum acceleration formula, please tell. What is the formula? And it occurs at extreme position. So A is 0.01, the omega is 120 pi whole square. It is 10 raised to a minus 2, 12 144 into pi square. All right. So this is 144 pi square and it is in meter per second square. So this is the very simple question, right? Formula based. Copy this. So read this question. In this question, simple harmonic oscillator has the amplitude. What is the amplitude? The amplitude is A and the time period is what? It is capital T, right? If the particle is performing oscillator, the SHM performing particle performing SHM, it may be oscillator, right? It may be particle, amplitude A, time required to travel from, yes, x is equal to A. So when it is at extreme position, it goes like this, coming back to the mean position, and this is the A by 2. So what is this time? Can you tell? Listen one thing. What the time it takes to in moving away from the mean position, right? This is the time t1, this is the time t2, the same time it will take. Are you getting or not? So do you know this time? Yes, the answer is t by 6. So this is the answer, right? Copy this. So read this question. In this question, particle of mass 10 gram, right? This is the mass 10 gram minus 3 kg, right? Simple harmonic motion, amplitude is 0.5 meter and time period is what? Say pi by 5 seconds. What they're asking? They're asking the maximum value of the force. So listen one thing. When the particle is performing oscillation, are you getting or not? Like this, right? So the restoring force towards the mean position always acts. Are you getting or not? So the what they're asking, the maximum value of the force. The force is what? Force is m into a. And what is the acceleration of the particle as a function of x? Minus m into minus omega square x.
So when the force is when the acceleration is maximum, force will be maximum. So what will be the maximum acceleration of the particle you tell? The maximum acceleration particle is minus a omega square. I am writing the magnitude. Is it clear? So what will be the maximum force? The maximum force will be equal to mass multiplied by maximum acceleration. So A max. So mass is given, A max is what? I am writing the magnitude. A is 0.5. This is 2 pi by t whole square, right? Or the omega you can find separately, 2 pi by t. This is t by 5 second. So if you put time period is pi by 5, so omega is 10 radian per second. If you know the omega, the maximum amplitude you can find. How it is? A value is 0.5, the omega value is 10 square. Is it clear or not? So it is 0.5 into 100 is equal to 50 meter per second square. Fine. So this is the maximum acceleration. So what is the maximum force? When the particle is on the extreme position, restoring force on it will be maximum, and the mass is 10 raised to a minus 2 kg. Please check this. This is 10 to the power minus 2. The maximum acceleration is 50. So it is 0.5 meter per second. It is in Newton. So the maximum force acting on the particle is 0.5 Newton. So the D option is the correct option. Right? Copy this. Read this question. In this question, what is given? The mean position, the displacement from the mean position are 4 centimeter, and displacement from the mean position is 5 centimeter. Its corresponding velocity is 10 centimeter per second. Its corresponding velocity is 8 centimeter per second. Right? As the displacement is increasing, the velocity will reduce. So the time period is we have to find. So V1 is equal to omega root over a square minus x1 square. If you make the square, V1 square is equal to omega square a square minus x1 square. Right? In the same way, the V2 square is a2 minus. I am not putting the value here. I can put the value later. Right? This is a square omega square minus omega square x1 square. A square omega square minus omega square x2 square. This is the equation 1, equation 2. Fine. Subtract them because a will cancel out. Minus plus. V1 square minus V2 square. It will cancel out. It is minus omega square x1 square plus x2 square. Fine. Take the omega square common. Are you getting? V1 square minus V2 square. So the omega square is V1 square minus V2 square upon x2 square minus x1 square. Fine. So the omega square is V1 square. Say 10 square minus V1 square minus V2 square. 10 square minus 8 square. x2 square minus x1 square. Fine. It is 100 minus 28 64, 25 minus 16. So it is 9, and this is how much? 36. Right? So no chok 36 omega square is equal to 2 by t. So t is equal to pi second. So this is the answer. Fine. Copy this. So read this question. In this question, particle executing SHM and the amplitude is 4 centimeter. At mean position, the velocity is maximum, and this is equal to a omega, which is given as 10 centimeter per second. The distance of the particle from the mean position, the distance you have to find, the velocity become 5 centimeter per second. Listen, when the particle is performing SHM, its maximum velocity is 10 centimeter per second, and slowly its velocity become 5 centimeter per second, decreasing, and extreme position the velocity becomes 0. So this distance we have to find. So I think you can do this. How? The formula we have omega root over a square minus x square. All right. So this velocity is 5. The amplitude is given, the velocity is 5 centimeter per second. Listen one thing, how to do. Although this is the formula we have, right? Also we can do this question by other formula also, right? This is the velocity, v is equal to, if x is equal to a sin omega t, what is the velocity formula? A omega cos omega t, right? We can do this in the time interval in the time interval domain. All right, listen one thing, what is the maximum velocity? Say 10. What is the velocity? It become 5. Can you find the value of the time t? We know the velocity 5 centimeter. Suppose it is at t is equal to 0 and after time t its velocity become 5 centimeter per second. So we have to find the time. So in that case v is equal to a omega cos omega t, because the maximum velocity is given. So it is 1 by 2 cos omega t, and this is equal to what? Cos pi by 3, cos 60. So pi by 3 is equal to what? Say omega t, right? So the omega t value is pi by 3. Now we have to find this position. The omega t value we know. How to find the position? The x is equal to a sin omega t, right? Are you getting or not? So the amplitude is 4 centimeter over here, right? 4 and sine omega t. What is the omega t? Say pi by 3. So it is 4 into root 3 by t. So it is 2 root 3 centimeter is the position. Okay, this is the one method. Listen one thing. We can do this question by this also, because we know the a. So if you put the value of a omega is equal to 10, a value is 4. So omega value we have found. This is 5 by 2. Now the velocity become 5. The omega value is known to us. The amplitude known to us. The x value we have to find. So this formula also we can apply. Although this is the method also. This is the method 2 you can write. This is the method 1 you can write. So this is 2 is equal to root over 4 square minus x square. 4 is equal to 16 minus x square. X square is equal to 16 minus 4 is equal to 12. X is equal to root 12 is equal to 2 root 3 centimeter. So this is the distance from the mean position where the velocity become 5 centimeter per second, right? Copy this. So read this question. In this question, particle execute SHM and the amplitude is 2 centimeter, right? When the particle is at 1 centimeter from mean position, the amplitude is plus a minus a. It is at 1 centimeter, right? This is the 1 centimeter. The particle is at this point from the mean position. The magnitude of velocity is equal to that of its acceleration. So here the velocity is v and the acceleration at this point will be the a. So they are telling that the magnitude of the velocity is equal to the magnitude of acceleration. So what is the velocity? The velocity we will write omega root over a square minus x square, and the acceleration is minus omega square into x, right? So I am writing the magnitude. So the velocity is omega a square minus x square, and the angular velocity, the acceleration is omega square, right, into x. So what they are asking, the time period of the oscillation they are asking. So 1 omega will cancel out. So root a square minus x square is equal to x, right? Is equal to x. So into omega, right? So if you make the square root, so this is equal to omega square into x square. What is a? A is what? 2 minus x is what? Say 1 square into 1 square. Listen, I have put the value. Listen one thing. the omega square is equal to a square minus x square upon x square. If you put a and x both in centimeter, so it does not affect the unit. So it is centimeter, 2 centimeter, 1 centimeter. So it is 4 minus 1 is equal to 3. So omega is equal to 3 is equal to 2 pi by t. So the time period will be 2 pi root 3 second. So this is the answer of this question, right? So the C option is the correct option. Copy this. So read this question. In this question, simple harmonic motion, the ratio of acceleration of a particle to its displacement. Tell me, acceleration is what? Say minus x into omega square upon x, right? So I'm taking the magnitude. So this is omega square. So what is this? Say angular frequency, right? So it is the square of the angular frequency. The C option is the correct option. Copy this.